Hi Ritu.
Hello, sir.
Hello Ma, how are you? Hi Samhita. So all of you, are you read all these colligative properties and at all?
Yes, sir.
Okay. So in last class we were discussing about here osmosis and osmotic pressure. Okay. So what is meant by the osmosis, Ma? The osmosis.
Process of flow of a solution from higher concentration to lower concentration.
Process of flowing of the solvent molecules from high concentration to low concentration through semi-permeable membrane we can call as a osmosis. What is meant by the osmotic pressure, Ma?
The pressure exerted to stop the flow osmosis.
Very good, man. So what is meant by the osmotic pressure means? Osmotic pressure is nothing but it is the pressure applied on the solution to stop the flow of solvent molecules from the high concentration to low concentration through the semi-permeable membrane is called as a osmotic pressure. Okay, so that already we had seen. Next, so how we are going to represent the osmotic pressure? Osmotic pressure can be represented with how we are going to represent the osmotic pressure. Osmotic pressure can be represented with pi here. Okay, and osmotic pressure is directly proportional to concentration and temperature. Osmotic pressure is directly proportional to concentration and temperature. So to remove the directly proportional, we are taking as a one constant. So what is the constant value we are taking means pi is equal to a solution constant S we are taking. So that is only we can write as a pi is equal to CST. In this one, C is nothing but molarity. How we can define the molarity? Molarity is defined as here number of moles of solute present in 1 liter of the solution. So in place of C, if you write N by V value, if you write N by V value means you will get as a pi V is equal to NST. You will get as here pi V is equal to NST. Clear? So this is about here osmotic pressure yesterday we studied. Now some questions are they're asking sometimes here. So what is the question they're asking means here isotonic solutions it is there. Isotonic solutions. What is the isotonic solutions, ma?
The solutions which have same osmotic pressure.
Very good, ma. Okay. The solutions which have the same osmotic pressure is called as a isotonic solution. So what is the isotonic solutions? Isotonic solution. So what is from the isotonic solutions which we can call as isotonic solutions means here the solutions which have the solutions so which have same osmotic pressure, same osmotic pressure, same osmotic pressure. The solutions which have the same osmotic pressure is called as a isotonic solution. Isotonic solutions. Okay, so if same osmotic pressure means that we can write as a pi 1 is equal to pi 2 we can write now. Pi 1 is equal to pi 2. Okay, so that means so pi 1 is nothing but osmotic pressure of the one solution, pi 2 is nothing but osmotic pressure of the another solution at the same temperature. Okay, so pi 1 is equal to pi 2. Now in this one, what is the pi 1, pi 2 values? What we can write as here? S is the constant value. S we can't change. Okay, and the temperature also we can't take. Temperature, same temperature we are taking here. We are taking at the same temperature. According to that one, how we can write the formula is concentrations only we can change. So that means C1 ST is equal to C2 ST we can write. Okay. So according to that, pi is equal to pi 1 is equal to C1 ST. Pi 2 is equal to we can write as a C2 ST. Okay. In this one, ST is going to be cancelled means what you will get C1 is equal to C2. C1 is equal to C2. Okay, at same temperature, if the osmotic pressures are same means here, their concentrations also it becomes as a same. Okay, so this also we can write as here. If you are taking on volume is same, we are taking both the condition concentration is nothing but mole number of moles of solute present in 1 liter of water only. Okay, so if the volume is same means then this also we can write as N1 is equal to N2 also we can write the formula. Okay, N1 is equal to N2. Clear? Equal concentrations equal concentrations of the solutions are they contain equal number of moles also we can say. Clear? Is any doubt is there about the
Yes,
formula?
sir.
Sometimes they're asking the question here. Okay, right. So now next hypertonic solutions. Hypertonic solutions. So what is meant by the hypertonic solutions? Hypertonic solutions. What is meant by the hypertonic solutions? Which we can call as a hypertonic solutions. Which we can call as hypertonic solutions. The solutions which have high osmotic pressure. The solutions which have high osmotic pressure. High osmotic pressure. The solutions which have high osmotic pressure is called hypertonic solutions. Is called hypertonic solutions. The solutions which have high osmotic pressure is called as a hypertonic solutions. Okay, and here some word also we are using. Sometimes we are using as here. Sometimes we can use some word also. Okay, so that we will discuss later here. So what is meant the hypertonic solutions mean? The solutions which have the high osmotic pressure is called as a hypertonic solution. So what is meant by the hypotonic solution? Hypotonic solution. Hypotonic solutions.
The solutions which have low osmotic pressure.
Very good, ma. The solutions so which have low osmotic pressure. The solutions which have low osmotic pressure. Which have low osmotic pressure. The solution which have the low osmotic pressure is called as here hypotonic solution. Hypotonic solution. Okay, so now all of you got the clarity here. So based on this one also sometimes they're asking the question. So what is the question they're asking means here? Let us see. So when raw mango, everyone knows about the raw mango. So before giving this clarity, I will ask one question here. Okay, so raw mango is there. So when the raw mango is placed in a salt solution, either the raw mango is going to be swell or it's going to be shrink. I'm telling that raw mango piece. So when you place in a salt solution, if you place in a salt solution, the raw mango piece is going to be shrink or swell. That is my question. Aditi, you got the question? Aditi, Ritu, Samhita.
Yes, sir.
Yes, sir. Could you repeat it once, sir?
Once again, I'm repeating the question here. So raw mango piece, when you place in a salt solution, okay, the piece is swell, the piece is strings, okay, so both none of the above. All of you will have pickle. All of you. Do you have any habit to have pickle?
Yes, sir.
What happened? Ati also is there. Kathy, Ritu, Samhita, Aditi.
It
Aditi's,
loses water.
if it is loses water means what happened, Ritu?
It gets
Either
shrink.
it shrinks ma here. So whenever raw mango, actually whatever we are having raw mango in summer season, okay, we'll get us some mango. Okay, sometimes we go for some visiting places and not only they used to sell us. Okay, they used to sell us a raw mango piece only. Okay, you are having raw mango piece na. The raw mango, if you see, means the size it will be more. So whenever you're placing in a salt solution, it's going to be spring. Sir, why it is going to be spring means here because of raw mango. The plant cells are mango cells are having more water content. Okay, whenever you place in a salt solution means whenever you place in a salt solution, it's going to be shrink. That means whatever the inside of the water molecule is there, that all water molecules are enters into the solution through the cell wall. That is only I told that. So cell wall is it act as a semi-permeable membrane. So due to the osmosis, water molecules which are present in a raw mango, that it is enters into the solution. So due to that reason only it is going to be swell, sir, here. Okay, sir, it is going to be shrink. Okay, the size is going to be decreased. So I think so you had seen or not, I don't know. In especially our area, they used to prepare as a mango pickle at summer season by getting the raw mango and all here. Okay, in homemade only they'll prepare. I don't know whether nowadays in your parents are preparing or not. So we had seen. Okay, so they'll prepare as a mango pickle so they can store for a long time. So we can use whole year also that one. It won't be so if it won't touch the water means nothing will happen, man. It stores 1 year also. Every year they used to prepare in the summer season. Okay, so whenever they're preparing that one means piece size it will be bigger. Okay, so after a few days, what happened? The size is going to be shrink and it becomes as a very soft also. So why it is becoming as a soft means total water is coming outside in the pickle here. Okay, so that's why the size is going to be decreased. The size is going to be decreases, that is only we can call as a string. And similarly, one more question is there. So when the raw mango piece is placed in a hypotonic solution, here hypertonic means high concentrated osmotic pressure solution. So mango piece is placed in a hypertonic solution means it's going to be shrink. Okay, now the second question is when the plant cell, okay, so when the plant cell or mango piece is placed in hypotonic solution, if it is placed in a hypotonic solution means then what happened here? Is mango piece is going to be swell, string, both, none of the above. Same questions only, same options only. When mango piece is placed in hypotonic solution, it shrinks, it swells, both, none of the above. You're telling that hypotonic is having low osmotic pressure. If it is going to be shrink in hypertonic solution means in hypotonic solution it is going to be swell only na. Okay, so what is the best examples are there means here yesterday also we discussed when flowers. Okay, so when the flowers are becoming as a dry, what you're doing, you girls are used to do you place in the water immediately. Okay, if you place it immediately means after 1 hour what happened again they look like it's a very fresh. Is it right? Is it right or not?
Yes, sir.
Okay, so why it is looking as a fresh means because of they absorb the water molecule through the osmosis process here. Okay, similarly here also when you place the mango pickle in hypotonic solution, if hypotonic solution means it's going to be swell. So whenever it's swell means that process only we can call as here hemolysis process. Okay, so when the plant cell is placed in hypotonic solution, the solvent flows from, okay, the solvent flows from hypotonic to into the plant cell. That time the size of the cell is going to be increased. That means cell is going to be swell. So whenever the cell is going to be swell, means that part only we can call as a hemolysis. Okay, that part we can call as a hemolysis. And here, whenever you place the plant cell or so raw mango piece in a hypertonic solution, if it is going to be strings, means that we can call as a plasmolysis. That we can call as a plasmolysis. So that I will write the statement formation here. So what this means here, when the plant cell is placed in hypertonic solution. When the plant cell is placed in hypertonic solutions, okay, it strings. The process is called plasmolysis. Okay, so what is the name of the process we can call? Process is called as here plasmolysis. Sometimes they're asking question also indirectly. Okay, and what is another one here? So when the plant cell is placed in hypotonic solution. When the plant cell is placed in hypotonic solution, it swells. Is called hemolysis. So what we can call, we can call as a hemolysis. So what we can call means that we can call as a hemolysis.
Sir, in plasmolysis process, the plant cell is placed in hypertonic or hypotonic solution.
Hypertonic, hypertonic are this one. Hypertonic
Okay.
solutions we are placing. Okay, if you place in hypotonic solutions, means with that we can call as a hemolysis process. Okay, so whenever it is going to be swells, means that part is called as here. So hemolysis. Okay, in this one what happened? Solvent molecules are enters into the plant cell. In the first process, what happened here? So solvent molecules are they flows from plant cell to into the solution. Plant cell into the solution. And one more question also it is there. For isotonic solutions. So what is the best example for the isotonic solutions means here? So if you got any fever sometimes,
Blood and saline, sir.
okay. Otherwise, whenever you go to the hospital, if you got some high fever and told me they used to give us a saline. You know that one or not?
Yes, sir.
Okay, saline and all we can call it. So generally they can call us a DNS, RLS, RNS, something they can call as a names. Okay, so whenever they place to the wines, that saline is going to be flows in a blood. Okay, that saline is flows in the blood. So why this flows in the blood means here, because of the blood and saline are having same osmotic pressure only. Okay, if both are having same osmotic pressure, mean that we can call as a isotonic solution. So what are the best examples of the isotonic solutions means? What is the best example of the isotonic solutions are blood and 0.9% of the NaCl. 0.9 percentage of the NaCl only we can call as a saline. Okay, how much concentration it has to be there? 0.9 percentage. So whenever they're having the same osmotic pressure, then only that liquid it flows in a blood. Got it, all of you? Still anyone you having doubt?
No, sir.
Okay, right. And based on this one also sometimes they're asking some questions here. Okay, so theoretical questions also they're asking. That's why I'm discussing this one. Next, here reverse osmosis, one concept it is there. What is mean by the reverse osmosis? Reverse osmosis. What is mean by the reverse osmosis? What is mean the reverse osmosis, ma? RO process generally we can call. Nowadays, everyone they are using as a RO process. Most of the people, every home it contains the RO plant. RO water plant generally we can call.
Here, in that, like the solute goes through the membrane, right?
Yeah,
Solvent, not solute. Solvent goes through the membrane to like to the it under the pressure.
yes, ma'am. That is one thing. Yeah. Okay. So RO water filters and all we are seeing by applying some pressure. Okay. In this one for filters, membranes we can using filtration purpose we are using as a some membranes and some inorganic salt also we can use as a membrane. You know that one Berkeley-Hartley method. In Berkeley-Hartley method, so what is the membrane they use means here inorganic salt. So what is the inorganic salt they used as inorganic membrane means here cupric ferrocyanide. Okay, so what is the membrane they used means here cupric ferrocyanide. Cupric ferrocyanide they used as a inorganic membrane. Inorganic membrane. Okay, so generally we can use as a plant cell, animal cell, pig bladder, parchment paper, cellophane, and egg white layer also we can use as a in membranes here. Along with that one, some inorganic compound also we can use as a membrane. Okay, so if we see in RO plants and total, we are using some solid substance, it will be there. Some solid substance candles type one solid white color solid substance it will be there. It has some small porous holes. They'll allow only solvent molecules. They does not allow the solute particles by here. It does not allow here solute particle. They allow only solvent molecules. Okay, sir, what is meant by the reverse osmosis means you are telling that osmosis means so the pressure applied on the solution to stop only solvent molecules. Is it right? So now, just to make you understand what I'm doing, I'm drawing the diagram once again here. So first what I'm taking here, so we are taking two compartments. So how many compartments we are taking here? So two compartments we are taking. One container is containing the two compartments. One container is contains two compartments. Okay. Okay. So two compartments. In this one is containing the solvent. Another one is we are taking as a solution. So you are telling that here some any this one it is there. Okay. Now from this side we are applying the pressure. So if you apply some pressure means solvent it stops the flow of solvent molecules through the semi-permeable membrane in the solution. Okay. Now if you apply excess amount of the pressure than that of the osmotic pressure. Okay, so when I apply more pressure than that of the osmotic pressure, when I apply excess of the pressure than that of the osmotic pressure means the solvent molecules which are present in a solution. Okay, the solvent molecules which are present in a solution that flows into the solvent through the semi-permeable membrane. Okay, through the semi-permeable membrane, the solvent molecules which are present in a solution that enter into the solvent is called as a reverse osmosis. So what is the reverse osmosis means? Reverse osmosis is nothing but it is the process of, okay, so when we are going to apply the more pressure than that of the osmotic pressure. The solvent molecules moves from solution into solvent through the semi-permeable membrane is called as a reverse osmosis. Clear? Sir, which water we are going to be purifying means salt water. Okay, sea water. Sometimes generally they're asking the question. So how we can purify the sea water into drinking water? Sea water into drinking water. Okay. So is any possibility is there to have the sea water, ma? Is any possibility is there to have the sea water? Any one of you? Is any possibility is there to drink the sea water? Ritu, Kathy, Samhita,
No, sir.
is any possibility is there? We can't drink the sea water. Sea water is very salty. So many minerals are there. Okay. So by using the RO process, we are making as a filter water so that it is useful for the drinking. Okay. So that's why nowadays everyone you're having water purifiers or not at home. Most of the people they
Yes,
are using as a water purifiers nowadays. Is there Ritu?
yes, sir.
Okay, so nowadays what happened? Technology is improved now, and behalf of RO water directly they are getting as a UV also, ultraviolet purifier also we are getting in aqua only they launch UV purifiers. Okay, so all this what is meant by the UV water filters means here they passes the UV light. So where they passes the UV light to kill the microorganisms which are present in a water also. Okay, so that's why here RO process is used. If you go for the big hotels and all, they use that as a RO process only in the purification of the water. Okay, clear? Next. So what is the another important concept we are having means here abnormal molar mass. What is meant with abnormal molar mass, ma'am? What is mean by abnormal molar mass? Abnormal molar mass. For that, I'll give one question clarity here. Abnormal molar mass. Abnormal molar mass. For example, NaCl it is there. If the NaCl it is there. If the NaCl is going to be ionized, what are the ions it is forming? Na plus and Cl minus. Okay. So in this one, what is the molar mass of the NaCl first of all? What is the molar mass of the NaCl? What is the molar mass of NaCl? Aditi, Kathy, Samhita. What is the molar mass of the NaCl, ma?
58.5 grams.
Very good, Aditi. So 58.5 grams. What is the atomic mass or ionic mass of the sodium in this one? Sodium mass.
23 and chlorine is 35.5.
Very good, Aditi. So sodium ionic mass is 23 and chloride mass is 35.5 grams. Okay. Now, so before dissociation, what is the mass of the sodium chloride? 58.5. Is that clear? So whenever you dissolve in a water, it undergoes to the ionization. Okay, that means we are getting as a sodium ions are separately, Cl minus ions are we are getting as a separately. Okay, now in Na plasma, in Na plus, okay, so the ion Na plus ion mass is equal to 23. That means from 58.5 to 23, the mass is going to be decreases or increases after the ionization. After the ionization, the mass of the salt is decreases or increases? That is my question. Make it fast. Aditi, mass is decreases or increases?
So can
I
you
didn't-
repeat your question again? I didn't hear you.
Okay, so once again, I'm asking the question here. After the dissociation, the mass is decreases or not in NaCl dilution?
Sir, it will decrease.
It will decrease. So starting the mass of the NaCl is 58.5, it is there. So whenever they dissolve in a water, Na plus ions are separately coming, Cl minus ions are separately coming. Okay, so what is the mass of the Na plus ion is 23 grams. So that means mass is decreased. Okay, so mass is going to be decreasing. So whenever the mass is decreased by the expected while comparing with the expected value, okay, so that means it is abnormal mass only, na? Sudden increase, sudden decreases are happening. If the sudden increase, sudden decreases are happening, mean that we can call as a abnormal molar mass. And one more question, exam point of view question here. Okay, for example, acetic acid. If the acetic acid is placed in a benzene solvent, then mass of the acetic acid is increases or decreases? That is my question. When, I'll write the question, ma. When acetic acid is, when acetic acid is placed in benzene solvent, placed in benzene solvent. Okay, the mass is option A, increases, decreases, option C, both, option D, none of the above. Option D, none of the above.
Increases.
Who gave the answer, ma? Ritu or Kathy?
Ritu.
Ritu, why it is going to be increases, ma? Whatever the answer, you correct only. Why it is going to be increases? When you placed in a benzene solvent.
Because of the molar mass.
Because of? Ritu, I didn't get clarity. Why the molar mass is going to be increases when you place in the benzene solvent? That is my question.
Because of the molar mass, sir, the benzene solvent has double molecules.
Very good, ma. So whenever you place the acetic acid in benzene solvent means, so acetic acid is, it becomes as a dimer. So how it is become as a dimer means it forms as a hydrogen bonding. Okay. For example, if you see CH3, C double bond O, OH. So this is the one molecule. Is it right? And I'm writing as another molecule here. Here C bond OH, double bond O, it is there. It is the one more molecule. So when you place the acetic acid in a benzene solvent means in between two molecules, it forms as a hydrogen bonds. If it forms as a hydrogen bonds, it forms as a cyclic ring. Then the mass also is going to be increases. That means monomer, it becomes as a dimer. Monomer, it becomes as a dimer. So whenever it is in monomer form, that means in CH3 COOH. So what is the molar mass of the CH3 COOH? Any one of you? What is the molar mass of the CH3 COOH? 32, 24, 4, 10, 6, 60 grams per. Okay, so what is the molar mass of the 1 mole of the acetic acid means here? 60 grams. So before dimerization, it has a 60 grams. Whenever it forms as a dimer, so then the whole mass, it becomes as a 120 gram. That means mass is going to be increases or decreases? Mass is increased or decreased when you placed in a benzene? Aditi, you got the clarity?
That will decrease.
No, ma, it's going to be increased. Let us see clearly. I'm explaining now. So when you place the acetic acid in a benzene, acetic acid becomes as a dimer. The monomer form of the acetic acid is 60 grams. Dimer form of the acetic acid is 120 grams. So 60 to 120 mass is increased only, na? Whether it is increased or not. Whether it is increased or not, ma. Aditi, Kathy, Ritu,
It is
Yes,
increased.
sir. Yes.
it is increased only, na? Okay,
Yeah, sir.
right, ma. So, one more question. Why the mass is increased in acetic acid when you placed in a benzene? What is the reason? Why the mass of the acetic acid is increased when you placed in a benzene solvent? All of you got my question? All of you got my question or not?
Sir, could you come again?
Ma. So why the mass of the benzene is increased when you placed in a benzene solvent?
Because of the double bond present in the benzene solvents.
Both double bonds are there. So you're forgetting here. So due to the presence of the hydrogen bonding, what is the reason means here? Due to the presence of hydrogen bonding in between two molecules. If you observe here hydrogen is there and here oxygen is there. The attraction forces which are present in between positively charged hydrogen and highly electronegative atom is called as a hydrogen bond. Due to the presence of the hydrogen bond, it exists in a dimer formation. Due to the presence of the hydrogen bonding, it is exists in a dimer formation. That is the reason. Okay, so why it is exists in a dimer formation is due to the presence of the hydrogen bonding. Got it? All of you got it here? Still anyone you having doubt?
Yeah, sir, got it.
Okay, so next one. So Van 't Hoff factor. Okay, so what is mean by the Van 't Hoff factor? I think so. This is the last concept. Van 't Hoff factor. Okay, Van 't Hoff factor. Van 't Hoff factor. So how we are going to represent the Van 't Hoff factor?
I.
How we are going to represent the Van 't Hoff factor, ma? Van 't Hoff factor can
The
be
letter I,
represented with
sir.
I, ma. So Van 't Hoff factor can be represented with I. So what is meant the Van 't Hoff factor, ma?
The ratio between the observed colligative properties to calculated colligative properties.
Okay, ma. So what is meant by the Van 't Hoff factor? Actually, Van 't Hoff factor can be represented with I. Okay, so how we can define the Van 't Hoff factor means here observed colligative property by observed colligative property by property by okay, observed colligative property by calculated colligative property. Calculated colligative property. Observed colligative property by calculated colligative property. So can we give any other definition? So this also we can write as a normal molar mass by normal molar mass by calculated molar mass. Calculated molar mass. Okay, so we can give another definition also. So what is another definition means here? Observed osmotic pressure. Observed osmotic pressure. observed osmotic pressure by calculated osmotic pressure. So we can write one more definition also. What is another definition we can write? Means here number of ions formed after association or dissociation divided by total number of moles of molecules. Total number of moles of molecules taken. So this is the one more formula. Okay. So what is the Van 't Hoff factor means? So these are the different definitions. So what are the different definitions we can give for the Van 't Hoff factor means here Van 't Hoff factor can be represented with I. So it is the ratio of observed colligative property by calculated colligative property. That is the one definition. What is another definition we can write means here normal molar mass by calculated molar mass. That is the one more formula. And observed osmotic pressure by calculated osmotic pressure. Okay. And what is another formula we can write means number of ions formed after the association or dissociation by total number of molecules taken. If we know the Van 't Hoff factor, so based on the Van 't Hoff factor also we can calculate degree of dissociation. Degree of dissociation also we can calculate. Degree of dissociation can be represented with alpha, and we can calculate the degree of association also. Any one of you know what is the formulas we are using to calculate the degree of dissociation? Degree of dissociation is equal to I minus 1 by n minus 1. Degree of association is equal to 1 minus I by 1 minus 1 by n. So these are the formulas we are using to calculate the degree of dissociation, degree of association. Okay. So based on this one, tomorrow we are going to solve some of the questions, and this Sunday you have a full colligative properties is the test. Tomorrow only numericals we are going to be practice based on the colligative properties. Clear?